Hi, we're going to be looking at some momentum and impulse word problems. Number one, what is the momentum of a 5 kilogram cart moving at 2 meters per second? So we're given two things. We're given 5 kilograms and 2 meters per second. So that tells me that the mass is 5 kilograms and the velocity is 2 meters per second. It's asking us, what is the momentum? So our unknown is momentum. And remember, that's a P in physics. M is already taken by mass. So our equation for momentum is P equals M times V. So when we plug in, we have P equals the 5 kilograms times 2 meters per second. So that's going to give us 10. And remember, our units is kilograms meter per second. So that is our answer for number one. Number two, if the above 5 kilogram cart was to bounce back and return with a velocity of -5 meters per second, what is the change in momentum? All right, so now it has maybe hit a wall and it bounces back. So remember that -5 meters per second means that it's moving to the left or down, but in this case, I'm just going to use left. All right, so again, we're given the mass of 5 kilograms. The velocity has now increased to a -5 meter per second. And yes, it is increased because it went from 2 to 5. The reason why it's negative is because it's moving to the left. Our unknown, well, we're looking at the change in momentum. So what's the new momentum? P. Our equation is the same. Momentum equals mass times velocity. So when we plug in, we have 5 kilograms times -5 meters per second. So that's going to give us a momentum of -25 kilograms times meter per second. So that just tells us that our momentum is 25, and it's negative because remember, it's moving to the left. So yes, momentum is a vector. It has that magnitude and direction component. All right, number three, how fast must a 25 kilogram cart be traveling to have a momentum of 55 kilograms meter per second? All right, so our given. Well, it tells us that our mass is 25 kilograms. And the momentum of the cart is 55 kilogram meter per second. And that's our momentum. It wants to know how fast are we going? So that would be our velocity. All right, so you can do this one of two ways. You can use the triangle. And remember, our handy dandy triangle has P on top, M and V on bottom. So when we solve for velocity would tell us that this triangle says that P is on top, M is on bottom. So you'd have momentum divided by your mass. So velocity is equal to momentum, which is 55 kilograms meter per second, divided by our mass of 25 kilograms. So when we do 55 divided by 25, we get 2.2. And remember, we're looking for how fast. We were solving for the velocity. Velocity is measured in meters per second. Next one, number four, how much mass does a truck have if it is moving with 7.6 meters per second and has a momentum of 16 kilograms meters per second? All right, so our given. Our mass is what we're looking for, how much mass, so that's our unknown. Our velocity is 7.6 meters per second. Our momentum is 16 kilograms meter per second. All right, so our equation for mass, remember we can use our triangle again. So if we are solving for mass, cover up our mass, momentum's on top, velocity's on bottom. So that means for mass, we would do momentum divided by velocity. So our mass is going to be equal to 16 divided by 7.6. So when we use a calculator, 16 divided by 7.6 is equal to 2.1. And remember, we were looking for how much mass. Mass is always in kilograms. So 2.1 kilograms will be our final answer. Number 5, if the momentum of a 245 kilogram speed skater is 400 kilograms meter per second, how fast is she traveling? So the momentum is 400, and the speed skater has a mass of 245, because mass is always in kilograms. And our momentum P is 400 kilogram meter per second. And our unknown was how fast is she going? So fast, that is velocity. So our unknown is V. And remember, we can use our triangle to tell us that to solve for velocity, we would have P on top, M on bottom. So for velocity, it would be P, or momentum, divided by your mass. So V is equal to, our momentum was 400, divided by our mass, which was 245. So when we do 400 divided by 245, we get 1.6. And remember, it's velocity. We were solving for how fast. So it will be 1.6 meters per second as our final answer. Number 6, what is the magnitude of momentum? So remember, magnitude is just the size or the number value. So what is the momentum of a 5 kilogram sparrow? So 5 kilogram, that tells us the mass is 5. Flying at a velocity of 12 meters per second. So our velocity is 12 meters per second. Our unknown was, what is the momentum? So P. And back to our original equation, P is equal to M times V, mass times velocity. So our mass was 5 times a velocity of 12. So 5 times 12 is going to give us 60. And remember, it's momentum. So our units are kilogram, meter per second. All right, so now we're going to start with our impulse word problems. And remember, impulse equations, there are several ways that we can find impulse. So we'll be using this equation for each of these impulse word problems. All right, so for impulse, number 7 says a 2.6 kilogram tennis ball initially at rest. All right, so we already have two pieces of information. We know 2.6 is the mass. And it says initially at rest. So that also tells me that the starting velocity or the initial velocity is 0 meters per second. And this tennis ball, initially at rest, is hit from a racket with a velocity of 64 meters per second. So now we're assuming that the final velocity of the ball, after it's hit with this racket, the final velocity is going to be that 64 meters per second. If the time that the racket and the ball were in contact with each other was 0.9 seconds, so the time is 0.9 seconds, then what impulse was applied to the ball? All right, so again, we're going to be using this long equation, right? But we're not going to use every single part. All parts of this equation, impulse, the change in momentum, m times the change in velocity, f times the change in time, they are all equal to each other, as you can see with all the equal signs. We just need two parts of the equation. So we know from looking at our givens, we were given mass, the initial velocity, the final velocity, and time. And we need to find the unknown. The unknown was, what is the impulse? So impulse, J. That's what we're looking for. So based on our equation, we need to find impulse. So we're going to have to use this part of our equation. We were given mass, we were given the initial and final velocities, and we were given time. All right. So although we were given time, we're not going to be able to use this part of the equation because we weren't given force and we have to have all parts. So we're going to use impulse, J, is equal to mass times the change in velocity. And remember that change in velocity means that we're going to do mass times the final velocity minus the initial velocity. That's how you find impulse with this word problem. So now we can just plug in. So we have impulse is equal to our mass, which was 2.6, times our final velocity was 64, minus our initial velocity, 0. So when we do 2.6 times 64, we're going to get 166.4. All right, so I know that impulse has 2 units that we could use, right? But for this word problem, we were multiplying kilograms, because the 2.6 was in kilograms, and velocity, so the meters per second. So again, impulse is the change in momentum. And we were solving for the change in momentum. So we're going to have momentum units for this one. We were multiplying mass times velocity. So we're going to have the units for mass, kilograms, times the unit for velocity, meters per second. So this would be our final answer. All right, number 8. What force is required to move a stationary car with a mass of 12 kilograms to a speed of 45 meters per second within 20 seconds? All right, so we're given a lot of information. First thing we were given is it's a stationary car. It's starting off at 0. So the initial velocity is 0 meters per second. The mass is 12 kilograms. It needs to get to a speed of 45 meters per second. That would be a final speed of 45 meters per second. And it needs to do it in 20 seconds. So that would be our time, 20 seconds. All right, and our problem was asking us, what is the force required? So our unknown is F. We need to figure out the force. How much force do we need to apply to this sitting car in order to speed it up? So looking at our equation, we need to know the force. We were given the initial and final velocities. We were given the mass of the car. We were given the time. So we have all parts to use this portion of our equation. So mass times velocity, the change in velocity, equals force times time. So remember that mass is times the final velocity minus the initial velocity equals force times time. All right, so our mass, we're going to plug in now. Our mass was 12 kilograms times our final velocity of 45 minus our initial velocity of 0 equals a force times our time. Our time is 20 seconds. All right, so for this one, now we can go ahead and start to simplify. So 12 times 45, because that minus 0 does nothing, right? So it's 540 equals force times 20. So remember, we need force on a side by itself. So we're going to have to divide the 520 by 20. So we divide by 20 on both sides, and that's going to give us a force of 27. And remember, force is measured in newtons. All right, last one. If a 4-kilogram baseball that is thrown with a speed of 60 meters per second comes to rest in a catcher's mitt in 0.8 seconds, how much force does the ball apply on the catcher's mitt? All right, so it's asking us how much force. So again, our force is our unknown. It says that our mass was 4 kilograms, and this baseball is thrown with a speed of 60 meters per second. So its starting off speed is 60. All right, so I am running out of time, but I wrote all the givens down. So mass, the initial velocity was 60. It comes to rest in the catcher's hand. So the final velocity is 0. The time was 0.8 seconds. So now we need to figure out the equation, right? So again, we were given time. We're looking for force. We know the velocities, the mass. So we're using the same portion of the equation again. The equation, mass times the change in velocity, so that final minus initial velocity, equals force times time. You plug everything into your equation, it should look like this. So you'll solve, remember you're trying to get force on a side by itself, so you'll divide by this 0.8 on both sides so that it cancels out. That gives you an answer of 300 newtons for the force for this problem. All right, thanks for watching. If you have any questions, let me know.